Discord still doesn't work for me, but now if I go here, that's unfortunate. Hello, come on in. I'm dealing with the usual tech problems. Perfect. This goes here, this goes there. There we go. Now that I have that, I can put that in our announcements chat. And all right. Great. Okay. Ba-bam. Chat's working. Cool. Wow, that is quite large. Okay. I'll just kind of make myself even tiny off in the corner. Okay. Sorry about that. Like I said, technical issues. But thank you all for coming. This is Intro to Virtual Reality with Unity. So we're going to talk about virtual reality in general, how Unity is going to help us make virtual reality apps and games and experiences and all that kind of stuff. And then we're going to try to do a demo. And I actually have some projects you can download right now. In the meantime, while I get through the theory, that way, theoretically, by the time that we come to that part of the thing, you'll follow along. I have two Quest headsets here that are capable of doing VR. So if one of like during the demo part, if you want to follow along, actually try it out. You can feel free to grab one. But I'll probably need one just to like start off with, and then I'll show you what to do from there. So here are the usual QR codes. If you haven't done so already, you can take a picture of that, but I assume most of you that are here have, so I'll go on. So here is the template for you. So if everything works correctly, you should just be able to access that link to download like a sample project. Even I will do it right now. So HTTP says this. So this is a example project that will showcase the concepts that we'll learn today. It's got if you go out to our GitHub, you can find the finished code in like a different branch. But this is the main branch, and it has some really basic scripts with like sort of like fill in the blank sort of things. And the best part is that I made this a year ago, and I forget how I made it. So I'm going to be following along with you trying to make it. So that'll be fun. But we'll kind of get to this in the later half. So for now, while I'll keep this up for like another minute or so, another thing you can do and download right now is if you have Unity Hub open, one of the things we're going to do is take a look at the VR template. So if you want to download that and play with that for yourself, what you're going to need to do is go to your Unity Hub, click on New Project, scroll down to VR, and then click on Download Template. In theory, this shouldn't take that long, provided that you have a good enough Unity installation. But basically, once this completes, that will also bring you to like a new project screen or whatever, and then you can create an empty project. Here you go. So once the template's done, we'll just call it like VR test or whatever. Create project, and that'll get going in the background. So that's the two things. If you want to follow along today, and I'll kind of give the forewarning or the warning that we're gonna try as best as we can to do like live demos and stuff, but VR is sort of finicky. So raise your hand, ask questions, have some patience, and we'll try to get through this together. But yeah, and the last thing you might need is the Oculus Runtime, which that is software that you need to connect to Quest to your computer to like do development and stuff like that. I believe this link still works. You can get it at this link here. You can also Google like Oculus PC download. Get the same thing. So are we good to go? Like, does that everybody have it who wants it? Yes, no, maybe so. No. So we'll get to that later on. But yeah, if you want the Oculus runtime, you have to do Windows. So, but yeah, without further ado, all right. So how I like to do this workshop is sort of I'll start off with like what is virtual reality? Because we're gonna make virtual reality games and applications, but it's my belief that before we kind of get into that, you should sort of know what the medium is about, the terminology within the medium, and how we can employ it. So I'm sure that if you've been in our lab or any of our events so far, you'll kind of know the gist of what you can do with virtual reality. But if you haven't, the goal of virtual reality is you want to completely immerse your users, your players, in a new virtual environment. And with that virtual environment, you have the freedom to do basically whatever. So you can put them in a space station. You can create a huge globe and put them in front of them. You can create like a sprawling desert. It really doesn't matter. And the goal with virtual reality is to just completely forgo the user's physical environment, the room that they're actually in, and replace it with something new. Oops. And as such, it's a great medium for games, obviously, because we can transport the player into whatever world we want and do whatever with it that we desire. It's great for simulations, so there's a lot of flight simulators, racing simulators, even driving simulators like trucks or whatever that take advantage of VR because you can actually simulate the machine or whatever vehicle you're operating. And it's also a great medium for like preserving spaces and doing exhibitions. So one cool application that I recommend you to try if you have your own VR headset or you come in our lab is something called Google Earth VR. That's a free application that you can get, but basically that allows you to go into VR and like visit real world like locations from VR. Like you can actually use like Street Views and stuff. So it's pretty cool. But that's sort of like the power of what VR will offer you. Um, next up. So here are some very popular games in VR, and basically, if I'm not mistaken, all but one is actually built in Unity, and the exception is Half-Life Alyx. They do their own custom engine called the Source Engine, but everything else is built in Unity. So you can kind of see off the bat that Unity is the a very good front runner in like the VR space. It's used to build basically the majority of all VR applications and games you see. And so some classics, of course, are Beat Saber. You got Social VR with VR Chat. There's many other games and platforms, and yeah, Google's Tilt Brush, which is like this, well, previously sold by Google, now something else, but it was like this 3D painting application. So all this stuff is pretty cool. We have this demo, which won't. I'll try to bring it up really. Yeah. Let's see. Nor do I have sound because this is the IMD classroom. But if I sort of pull this over. So this is one of my favorite games. It's called Bone Lab. It basically tries to take as much advantage of VR as you possibly can. So you can see here we got all types of crazy interactions like prying elevator doors open. You have an expansive world, lots of different environments. Like this whole combat thing, it's all physics based, so you can actually like do stuff like push blocks around, like hold on to an edge of the crowbar. Really crazy types of interactions, and this is all possible. Granted, in the context of tonight's workshop, we're not going to be getting to this level of interaction because that's that's a lot, but it sort of just gets you in the mind space of knowing what's possible. Next, let's see what else we got. Oh, here we go. Experiences. So this was like the Google Earth VR thing I was talking about earlier. It's like this really great medium. You can actually just put people into real world locations using VR. And if you think about it, like this is also a great way to preserve spaces. So one thing I like to do is every time I move out of my dorm or apartment, I do like a 3D scan of the room. And that way I can like later on in life, I suppose, look at it in VR and be like, oh, I used to live here, even though I'm long gone. So, you could do stuff like that with this, with the knowledge you learned today as well. Next up, we have simulations. So this is a demo from a project for my job way back when. Kind of outdated actually, but we can also use VR in as a utility. So this is something I made last summer, but basically it's like the goal here was to visualize climate data on a virtual globe. That way, instead of viewing 2D diagrams you print on paper, why not actually show the Earth, put it on the Earth and look at it. So pretty exciting in that regard. And yeah, so that's enough of that, what VR can be used for. And now we're going to go into some terminology that's kind of helpful for you to know while you develop the games and just work with the medium in general. So the first one I'd like to discuss is the idea of inside-out and outside-in tracking. Basically, all VR devices today use one of these two mechanisms, and that basically is the mechanism that determines how your VR headset, your VR controllers determine where they are in your room and how they're oriented. So there's two ways of doing this, and they're called inside-out tracking and outside-in tracking. And as the name implies, it's sort of it's a measure of like from what perspective you're determining your location. So the Meta Quest devices, Oculus Quest, whatever you want to call it, they're all an example of what's called inside-out tracking, and that is because we have cameras on the headset itself that will basically look around the room and be like, okay, where am I in the room? And so I think there's an algorithm called SLAM, or like a technique called SLAM, which is simultaneous localization and mapping. Did I get that right, Ian?
Yes.
Okay, cool. But basically that sort of constantly takes in your feature points from the interesting stuff you have on the wall and calculates where you are in the room. So this has become increasingly popular in the recent years with like the rise of Quests. It's gotten really good, and as far as I'm willing to bet, it's probably overtaken outside-in tracking in some regard, because it's convenient. You can just do all from within the headset. You don't need any sort of external sensors. So on the contrary, you have outside-in tracking, which is basically you have two what are called like devices that you kind of mount on your walls that have sensors, or not sensors, but they sort of allow the device to track itself by like sort of doing something externally. So the example of this are what are called lighthouse stations. So for every other like PC headset, it usually uses what's something called base stations and lighthouse tracking, and that basically means, like I said, you mount like these little cubes on the corners of your room, and they sort of emit light. They emit light like a wave of laser light. Let's see if I can find an example of this. There's a really cool video. Oh, here you go. This is one of my favorites to show off. So these are cool because what they do is there's no cameras involved. And what instead happens is that these boxes you mount, they sort of sweep the room in these horizontal and vertical fashion many times per second. And how you actually determine location out of that is each device will be sort of mounted or decked with like these little IR light sensors. And basically, the device does a calculation where it figures out, at what time did this point on the device get hit with the IR wave. So you can kind of see that in the video with like all those little dots flashing. And basically, by taking that into account, you can do some math, and then you can actually figure out where the device is in the room. And it's pretty cool. Now you might be wondering, like, why would you ever want to do outside-in tracking when inside out is so convenient? You need external sensors, blah 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 blah. And the answer to that is because outside-in tracking provides the benefit of being able to have stuff behind your back, or sort of track things that aren't in view of the headset. So you can imagine, if I have this Quest on, right, it's like this, and then like I'm like playing an archery game, right? If I draw my like virtual bow back or whatever, I'll try to get the camera like this, and this controller goes behind my back, then this headset has no idea where it is because all the cameras are front facing. So you have, in that case, the headset sort of has to guesstimate, based on like, the accelerometer, other sensors within the controller, how far it could have gone. But there's a loss of precision there, right? So the longer it's out of the view, it gets more unstable. You don't know where it is. So it's something to consider if you build like a game like that, right? Because if, archery, going behind the back, well, if your controllers aren't reliable, you might get some weird funkiness there. But yeah. Another important thing to consider when you're making VR games is the idea of standalone versus tethered experiences. So the goal with this is to basically, it's where your application or game will run. So the industry trend is to have games more and more games are becoming standalone, and what that means is that basically the whole game can run off of like a mobile device like the Quest itself. There's no external PC, no external wires, blah, 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 blah. The whole game runs on the headset itself. And you can basically think of the headset as a glorified Android device, because that's really what it is behind the scene. And so the benefit of that is it's very portable. You can basically take it, run it everywhere. But you sacrifice a lot in terms of fidelity, because now you're running on mobile hardware. You don't have the power and luxury of the PC to give you all those fancy graphics. You have to tune everything down. On the contrary, we have tethered experiences or tethered games. So if you ever like plug in a headset into your computer to play something, it's obvious you sacrifice that portability. But now that you're connected to a powerful computer, you can do way more visually, high detailed things. Like you could have super high detailed like environments, like let's say like a very highly detailed forest or something. That becomes easily possible with tethered experiences. But like if you're trying to actually start a business making virtual reality games or something like that, you can't. It kind of sucks because you can't just target the tethered experiences, because so many more people have standalone headsets. So you're just kind of shooting yourself in the foot if you don't do that. So you kind of have to have standalone in mind in some capacity, because that's where the majority of VR users are currently. But oh well. Next thing. I did not set that title. That's funny, although that's what I would say. These are, so in addition to the traditional VR headset, VR controllers, we also have a whole range of peripherals that you can attach. And these are fun. Each one of these has like Unity APIs, whatever. Um, but like we have everything from like what are called full body trackers. So you can see there that there's that little puck in the top left. And the idea of that is normally you can only get where your hands are when your face is through the tracking, but you can get these additional sensors that you can sort of mount throughout your body, like your hip, your legs, your feet, etc. And then instead of just being able to just be this sort of floating legless avatar, you can now actually do stuff like kick your opponents. You can dance or whatever. I don't know. So like a really cool experience is what's with I think Blade and Sorcery, where you can just like you can get like lightsabers and then like drop kick people and then like that kind of stuff, which is fun. Other kind of peripheral inputs are like eye and face tracking. So some headsets have special sensors that can basically look. They have cameras to look at your eyes and your face, and then they can actually map those into digital inputs that you can utilize in your application. So if you want to like have an item do something whenever you look at it, that's possible. If you want to like map like your facial expression to some digital avatar, that's possible. But yeah. And then lastly, we have like haptic stuff. So like we have in our lab upstairs, we have what's called the B haptic suit, and basically those are a series of motors that you strap to yourself, and then whenever you get shot in the game, you'll feel it. You can program that within Unity as well. There's all that fun stuff. So this is not. So this is obviously some niche hardware, but it will like it's just something fun to think about. That we have most of the stuff in the lab upstairs. So if you want to employ this in your project at all, in either as part of the club projects or in your own personal usage or exploration, feel free to do so.
Actually, everything except for the last item.
Yeah. You know what? Yeah, you're right. Well, we don't really have, gloves yet.
I don't know.
Yeah, not till Lucas hits us up. Okay. Once again, we're brought at this age-old question: why Unity, especially recently? We kind of covered this last week in some detail about how Unity takes care of a lot of stuff for us, and the sort of rhetoric is the same. Only with VR, it's even more prevalent, because while you can sort of do like make your own games without Unity, it's a lot harder to do VR because there's a lot more math involved. For example, like because these are lenses and like physics dictates that like lenses will bend and shape light, you have to do some additional math to distort the image that you output to the headset to conform with the headset's visuals. And I don't even know that math, so Unity will do it for you, which is really nice. Furthermore, especially in today's market where the Quest is king and there's like a whole wild west of VR headsets that exist on the desktop side, Unity has a nice multi-platform support that will let you just target all of these with ease, and you don't have to worry about all this. You usually don't have to worry about specific conversions or implementations for specific headsets. Okay. And once again, before we kind of continue, just to remember our fundamentals from last week. Unity, we have three very important concepts that sort of dictate how we think of any sort of Unity concepts. We have a scene, which is basically our environment that we sort of stage our world in. Like, for example, this classroom, IMD Visualization Classroom 3258, could be an example of a scene, because we have an environment here, we can put stuff in, we can arrange stuff, tables, etc., etc. We have game objects, which represent like the basic building blocks of stuff that we put in the scene. So they're like containers that we can put stuff in. So, for example, Ian can be represented as a game object with many more game objects within. Like he has a game object for his hands, his glasses, etc., etc., etc. So we can structure like that. And components are how we make game objects do something. So a game object by itself is just going to do nothing. Components is how we actually make it like draw something like a mesh, or like have a floor material, or have a wood material, have a game object play a sound, have it like keep track of points. Basically, for anything to happen, it has to be a component on some game object. So once again, I know I'm being sort of verbose, but it's important to remember. Scenes is what you use to set your objects, much like in the theatrical sense. It's like a stage for you to put things. Game objects are building blocks or containers to arrange stuff, to hold our stuff, and components are the things we put in those sort of building block containers to make them do stuff. Okay, so if you want to know in a technical sense what Unity is doing behind the scenes with all like the whole VR framework, voila. But that by itself, that's kind of meaningless. Look at the hell. So basically, we have like 3 different kind of things that are going on. They're color coded green, blue, and red. So we'll go to this next slide. So Unity sort of provides VR through 3 different steps. We have what are called provider implementations, the XR plugin framework, and developer tools. So the stuff that's in green are called provider implementations, and that's basically Unity's way of communicating with specific headsets. Like I have a provider implementation that allows me to connect to OpenX or to Oculus headsets. I have a provider implementation that lets me connect to the HoloLens. I have a provider implementation that lets connect to the Vision Pro, et cetera, et cetera, et cetera. Huh? Pimax too, yeah. So this is how Unity actually communicates with like the headsets itself. But the nice thing is that if you kind of look at it as like a flowchart diagram, Unity is doing this all for you. So you never have to work with this yourself. Unity is just behind the scenes, allowing you to communicate with all these. Then in the middle, we have what are called what's called the plugin framework, and then this is basically a collection of services that Unity is doing for you behind the scenes to make stuff easier. So that's stuff like doing that distortion correction, doing like providing physics, doing like what else is here? Everything else that Unity does well. So like raycasting and UI and all that. That's all the Unity's tools coming together to sort of make this nice development experience for you. And then lastly, we have developer tools. So these are things that are built on top of Unity to make development for you even easier. We'll look at a fantastic example of this later called the XR Interaction Toolkit. But basically, this is like a sort of additional functionality that is provided on top of Unity that you can use to build your stuff out, build your experiences, and it's pretty, it makes things a lot easier. And then finally, in purple, we have whatever your stuff is that you're building. So this is sort of a sideways hierarchical structure. But once again, the goal is that you have these layers of foundations and abstractions that Unity is giving you behind the scenes to make whatever you're doing much easier. So, all right, we got that. Next up, we have useful software for Quest development. So you can't really talk about VR development without looking at Quest in particular. So we have a variety of apps here that are very useful. So on the very left, we have the Oculus Runtime, like what I mentioned at the beginning of today's workshop. This will allow you to tether. Oh, is it kind of hard to see? I can. This will allow you. The Oculus Runtime will allow you to connect a Quest headset to your Windows computer to either stream PC games, but in our context, to actually interface with Unity, and like so that you can just like plug in your computer and run it off your computer, which has benefits that we'll get into later. We have what's also called the MetaQuest Developer Hub, and this is a separate app that allows you to manage the installation of apps and experiences or standalone experiences on the headset itself. So if you make like your game and you want to put it on your Quest to show your friends to see, if you eventually want to publish it on the store for even more people to see, the MetaQuest Developer Hub will assist you in that, and it has some nice features like it'll allow you to turn sensors on and off on the device. So for example, one thing I know it can allow you to do is turn off the proximity sensor. So basically, usually there's a sensor that in the middle here that tries to detect when your face is on it. So when your face is on it, the screens turn on, and when your face is not on it, the screens go off. But obviously, if you're developing, you have to go like this and on and off and on and off and on and off, et cetera, et cetera, et cetera. You can turn off the proximity sensor and keep it on, which is nice. And lastly, last but not least, we have an app called Virtual Desktop. This is my favorite way of using my Quest with my computer when I develop. It does cost, and it's a Windows/Mac application, but the Mac is an asterisk because the Mac functionality doesn't do it won't help you there. It's mostly for viewing videos off your computer. But basically, case in point, It's an alternative way of streaming or wirelessly connecting your Quest to your PC. And the benefits it provides is it's very fast. It's even like less. I find it to be less hassle overall than the actual Oculus solution. It's very simple to get up and going, and you can even stream it over the internet. So theoretically, if you have your PC in your dorm and you're in a pinch and you need to stream it to, I don't know, weird use case, but you can even like stream the VR over the internet, and it's really fast and responsive. It does cost like $20, but it's one time. And I think that if you're going to be doing Quest development long term, this is a very nice application to have. The only downside of it is that it doesn't stream the hand tracking data. Only the Oculus runtime does that. So if you're building an application that you want to like have hand interactions in, like being able to use your hands to pick up stuff, you're stuck with the Oculus runtime. But that's not in the scope of today's workshop. So for all intents and purposes, you can do that. Now, a disclaimer. For all of you who have Macs, I'm sorry. You can develop apps for VR on a Mac. It's just mid. And by that, I mean, so you can, yeah, so what we saw last week is what Unity provides to allow you to debug stuff or to help develop your application faster is something called play mode. So basically, you can set up your scene, hit play, and then you can like make changes to the scene as you're like sort of testing it. You can like move stuff around, change values in your components, yada yada yada. But the problem is on Mac, there's no runtime there's no sane runtime. There's a way to maybe get it if you're super tinkery, but there's no, Oculus doesn't provide any support to connect a VR headset to a Mac, nor does Virtual Desktop. So you have no way of actually sort of employing Unity's features to have a nicer debugging experience, which kind of sucks. But you can, what you can do is you can still build. So you can do, what you can do is you can build like a standalone version of your app every single time and deploy it to the Quest, and that still works. But because you're doing a full build, like you're fully packaging everything up and then putting it on the Quest, you lose out on play mode, and that takes a lot more iterations. It takes longer. So it's not impossible to do VR development for the Quest on the Mac. It's just much more of a hassle. There is a way sort of around this. I don't know if I will get to it today. If you're really interested, you can hit me up on Discord, and I'll show you. But yeah, it's something to take a note. So all that being said, we are now finally ready to talk more about the actual VR implementation in Unity. I have these slides here that kind of go over how you create a VR project from scratch, but you won't, like, this is if you're going to go from bare bones, so I wouldn't really recommend that. Or I wouldn't recommend that for today, but you can look at it later on when I publish the slides if you're interested. So we can get right on to what's called the bread and butter of making your VR experience, the XR Interaction Toolkit. So the problem that we're trying to solve is, fantastic, we connected our VR headset to Unity, but how do we actually like sort of design our game to do stuff with the VR hardware? Like, how do I make it so that I can pick up a virtual football and throw it? How do I make it so that I can move the player by teleporting them like based on like wherever their controller is pointing? Out of the box, Unity doesn't give you that much. So the XR Interaction Toolkit solves this problem by providing all these functionalities to you as a developer. It's one of those like plugin frameworks or whatever the red thing was on the slide a while back. It's one of those nice developer tools that help you sort of shape things. And what's also important is that this sort of, the concepts you'll learn here sort of carry on throughout different like sort of so-called interaction frameworks. It's mostly the same. Oculus has their own version of this, but this one is more well-rounded. It will apply to basically any VR headset. So here we go. So like I said, the Interaction Toolkit will help us create interactions between our controllers, our player, and the stuff within our game. And the other thing it will do is it will allow us to define how we can move the player throughout the scene. There we go. So here is another like fancy technical schematic of that. But much in the same way that the Unity thing does, it's sort of trying to take whatever specific controllers you have and then make them add abstractions, make them more simplified so that your game doesn't have to worry. So it does this in 3 different components. We have one interaction manager within our scene, and basically its job is, as a manager, it just orchestrates all the interactions in the scene. So it's keeping track of everything that can be interacted with, such as like a football. You can interact with it, you can pick it up. Virtual weapons, like you have a gun, that's something to be interacted with, and it keeps track of things that can interact. And so, what are these things? Well, these come in the form of interactors and interactables. So, interactor, it's sort of a act, as the name implies, is an actor. It's these are things in your scene that are going to be initiating interactions. So, for example, we can have like our controllers more or less are forms of interactors because that's what they're going to be doing stuff with, like with the objects within our scene to move them, use them, activate them, yada yada yada. So basically, conceptually, if it's like actually like acting on something, it's probably an interactor. And on the contrary, we have interactables, which basically is anything in the scene that can be interacted with. So any sort of like I said, the football or beach ball, menus and stuff, those are all sort of interactables. So, yeah, so that sort of, these sort when you do a VR game, basically the gist is you're going to break your game conceptually into interactors and interactables, and that way, that's how you're going to think of actions between them. So there are also what are called interaction states, and this basically dictates like the different sort of modes or states that interactables can be placed in, or like how interactors and interactables can communicate to let them know what's happening. So there's 3 main ones, and they're called hover, select, and activate. So hover basically is just the interactable telling this the interactor telling the interactable that you're kind of being hovered. The user is thinking about using you but hasn't done anything yet. So you can imagine if I had my hand as an interactor and then I'm like this, I'm in a hover state with Ian because it's like I'm not touching him yet, but I could. So yeah, so this is a hover state. So basically, like if I considered like me about to pick something up, hover, because it's like I can. It's like this is what I'm focusing on, but I haven't done anything yet. I'm not actually picked it up on anything. The next sort of state is called select, and so the goal of the select state is basically you have decided to select something for interaction. So you are interacting with it. You are, for example, holding the controller. Right, so I'm not gonna grab Ian, but you can see here like selectable. You have selected something. In the context of UI, it's like if you, I think it's like if you click on a button, although I don't know. I forget. So yeah, and last is what's called an activate state. This is sort of like a even more selected state. So basically, the best way to think about it is if something has a trigger. So like literally like this controller, an activate would be me pulling the controller or the trigger on the controller. This would be an activate state. And this is useful for stuff like a flashlight, right? So you can pick up the flashlight, but if you actually, and that would like get you in the select state. But if you actually want to turn the flashlight on to show something, that would be the activate state because you're activating the flashlight's trigger or whatever, and then that is starting to, that'll turn on the light. So that's an activate because you are activating the interactables. So whether that be turning on light or perhaps like with the virtual like pistol, you could pick up like the pistol and then you could pull the trigger and it fires something. So that's the activate state. And that is basically, really all you need to know to kind of start thinking about how you design things. So I have a little quiz, not really, well, kind of, but so I would like for you to classify some of these. The first one up The first one is a laser pointer selector. And so basically, this hypothetical device would allow you to shine like a virtual laser pointer, and then whatever that dot lands on, you can do stuff with. So, knowing that, is that an interactor or interactable? You can either shout in unison or raise your hand. I'm okay. Correct. Fantastic. A beach ball. You can pick it up, you can throw it, you can pop it. I don't care. Is that an interactor or interactable? Or what? Great. Interactable. A flashlight. You can pick it up, you can turn it on, you can check it, yada, yada, yada. Interactor or interactable? Fantastic. Laser gun. You can pick it up, start shooting bullets, blah, 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 blah. Interactor, interactable. Maybe that was a bad example to do a laser pointer, but the laser gun would purely be just firing laser bullet things. It doesn't interact with anything else. So, yes, it is interactable in a very... we're not going to confuse ourselves for. Okay, last but not least, a hand grabber. Basically, if I have my hand, I can... pick stuff up. Not like that. So is it interactor or interactable? Interactor. Correct, interactor. So that is sort of the, like I said, it's the categorization that you'll do, the classification you'll do, and everything will be seen. So yeah, like just start kind of thinking about your stuff in this way, and that's kind of how you're gonna do it. So I believe, okay, so we're gonna now actually employ this terminology to build something in Unity. But before we do that, we're going to take a little detour to look at the VR template. Whoops. Okay, Unity. Hello. You know what? That is true. Or maybe you didn't like that I... maybe he didn't like that I did that. So let's try again. So beforehand, Unity's default VR template was really garbage. Actually, like it really, like literally did not work out of the box, and I'm not kidding. So I had to like make last year. I had to make like slides or like, oh yeah, the VR template exists, but don't use it. But now you can actually use it, and it will beautifully demonstrate all the stuff we have learned so far with the interactor interactables. So I will actually sort of try to demo it to you right now. And when I'm done demoing, any of you, if you want to come up and try it out, you're more than welcome to. So you can also see some stuff that you need to do to actually get the VR working. So where is everything? Is that even upstairs? Oh, we can do it then. Well, I see that Raymond was playing Beat Saber before this. So on a quest in particular, I don't have a slide for this in particular, but it's useful to know. If you want to get your PC connected or your Quest connected to your PC, you'll have to put it what's called Quest Link mode. So you'll open up like the main Quest menu, and you'll see like a button that says Quest Link. You may have to activate it in the settings under, I think, System Quest Link, and there's like a little toggle. Once you have that on, you'll see this option. You plug it into your PC. And once you have the Oculus runtime installed, as this is going up now, perfect, you will see your device pop up here usually. It might take a few restarts. This is complaining that it doesn't have a microphone, but that's fine because that's not really doing anything with microphone today. And then all I do is now I can hit launch from within the Quest, and then it will go ahead and connect me to my PC. right. So that's launching. Another thing you might have to do, especially if you swap back and forth between Oculus and some other, like if you use Steam VR, if you're connecting to your Quest like this, what you usually have to do is come into the settings here under General, and then there's this like row here that says OpenXR Runtime. This usually has to be, you have to press this button, set it as default, because sometimes like applications will struggle to connect. Also, if you click on it and it doesn't do anything, you have to make sure that whatever device you're using, like you're an administrator on that device. So if you don't have admin perms on your device, you have to switch to an account that does and do it from there, because for whatever reason, it requires full admin to do it. Even if you run it as administrator, it won't do anything. But okay, so now I'm here and I can see like the sort of Oculus menu here. And now with that being done, theoretically, all I have to do is come here, hit play, and pray, and yay. Oh, okay, good, yay. Everything's just loading in. So, okay, thank you. So this is the VR template that Unity provides you. It kind of, like I said, it not only like gets you in the VR space, but it also it'll, like show you a bunch of, or it'll show you interactable frameworks. So this will, so this little panel here shows you like how you structure your game objects to get everything working, and we'll look at that later. Blah blah blah, tutorial, what interactable. And so what some cool stuff is that the interaction toolkit lets you do is actually move around. So I have my thumbstick here, my controller, and I'm able to sort of move myself around like this. I also can actually teleport myself, but that would require the right controller, which I do not have presently. What a shame. We can do stuff like, you can see here, we have like our interactor as like a laser pointer. You can actually drag this stuff around. It even works with UI. So if you're, when we learn about Unity UI stuff later, not tonight, but you can do stuff like interact with UI elements, buttons, the whole shebang. And last but not least, here's our example of interactables. So we have this beautiful pile of interactables. So I can just grab it, manipulate it, drop it. You can do so, I think, to the laser. So I can grab it from a distance. I can chuck it, sweep the flow of, it's all fantabulous. And some more advanced things you can even do, which we won't really cover today, but sort of just put your radar on, is that you can actually configure interactables to only allow you to physically interact with them in certain ways. So you'll notice here when I sort of have this J whatever doohickey, when I had it, there you go. It immediately snaps my hand. It'll always, whenever, no matter the angle that I grabbed from, like it'll always sort of come to this shape where like it's pointing outwards and it's perfectly aligned with my controller. Versus like this cube in the distance, it'll match the way I picked it up. That's something you can configure. So whenever you pick something up, it's always in like the correct, orientation. So you can imagine if you have like a pistol or something like that, you'd want to have it like this, where like it faces correctly instead of you kind of picking up it like not the right way. Other cool things you can do is you can actually lock like movement and rotation to specific ways. So for example, like here, we want to be able to like turn this wheel thing, but we don't want to actually like physically move the wheel, nor do we want it to rotate in any other axis besides like the spinning like forward axis here. So that's another thing to do with this toolkit. Super cool. All right. Well, that's enough of that. Now we're gonna actually make something. Okay. So, if you were following along, this is today for tonight. We are gonna attempt to build Femur Arena. It is okay. So it's a parody game of Bone Lab, which is what I showed earlier. Here, with all the crazy sort of interaction, right? So, oh, that's a fun thing to start with. So all this crazy interaction, we're gonna try to implement like a little mini version of this. The only catch is that we're basically implementing the Netflix adaptation of it. So, you know, very low quality by comparison. You know, but whatever, you know, all in good fun. So, oh yeah, so here, if you kind of follow along after the fact, this is like the directions you'll need to do to turn quest icon. So what I'm gonna do first is I'm going to open the project which I downloaded. I did download it. Hold on a second. It says a zip, so that's I have to extract it first. Never fear. Okay. Oh, I even have it here from last year. That's crazy. Boom, boom. I paste. I extract. And okay, here we go. I'm gonna open it. Opening it. If you happen to install this on your own machine and it complains about the Unity version not being quite the same, that usually is okay, so long as you're not like if it's more than 2022. Yeah, you'll probably be fine. No biggie there. So I'm just gonna wait for this to load. And this is also we're also gonna cover some more scripting things. So I'll also like show you how we'll kind of look at a more C#-esque. We'll look at more C# code in this regard. And of course, you know, if you have any questions while I'm doing this, feel free to raise your hand. If you have any like conceptual questions about like, oh, if we were to do X, how do we do that? Like, how do we actually implement that in Unity, or with the concept we've learned? By all means, it's cool with me. Let's see. So what is here? While this loads, another Unity feature. Or what? Yes, we right now we have 2 of our own, but through my neighbor we'll have 3, and through pending once we get our purchases out the door, we'll have a Quest Pro that people can use, and you didn't hear this from me, but we are hopefully likely to get some Quest 3s. Fingers crossed. We requested them, and it looks like it will work, unless there's like some crazy budget cut or something like that. But
Budget cuts are apparently going to be $30,000.
Oh, wait.
Total across all clubs,
who knows? Anyways,
according to a source.
according to us, okay. Well, we're hopefully gonna get Quest 3s. That way, you have even more stuff to play with. The other thing I want to mention is that in Unity, if you ever want to build, here we go. So now we have our project open, and I'm gonna come. There's one scene in this folder called game. That's where we're just gonna build everything. It has a bunch of starter stuff. So this is sort of the arena that we'll be working in, per se. And the goal of this game is we're gonna have a bunch of these little crab things spawn in on the on the outskirts of this radius here. They're gonna approach the player, and when they get close enough, they're gonna jump in the air and attack you. And the only way for you to fend them off is to shoot at them with this with your little pistol type thing. But yeah, so that's a goal. In terms of what I was saying before, if you ever want to build your Unity project standalone for like the Quest, so that you can actually have it run on the Quest itself, not just your computer, what you have to do is go up to File, Build Settings, and this opens this window here. It's spawned off the screen. Hello. And so this is basically how the window you use whenever you have a Unity project, VR or not, and you want to publish it like as a final shippable game. But to get it into for the Quest, we need to switch it to Android mode, because I am forgetful. I forgot to install the Android module, so we can't actually switch to it yet. But this is a fantastic example because I can show you how you'll probably encounter the same thing. So you can click this button here. This is install with Unity Hub, but you basically have to install Android support within your Unity version. So to do that, you can come to this Installs tab here. Whatever version you're currently using, you hit this little settings here. You click on Add Modules, and then you get this full list of platforms you can support. For Android, you will just need this Android build support. And once you do that, you'll be able to build it for the Quest. There's some additional steps you might have to take, but those are outlined in the slides, and we're not going to be building standalone tonight. We're just going to be building it for the PC. Oh, it's faster, but just so you know. All right, now we have our little arena thing, and let's see. I will show you what it looks like out of the box. Let's see, so I'm going to put on my headset, which I put here. All right. I hit play. I'm in this, now I'm here. I see I'm in this sort of expanse. You'll see I have this floating laser pointer here, and this laser pointer thing here, that's where my left controller would go, but I don't have my left controller right now, so that's sort of floats there. I have this thing on the floor, this gun thing, but I can't actually pick it up. So what's up with that? Well, that's sort of the stuff that we'll need to fill in right now. So the first thing to take a look at is, how is Unity actually representing our VR scene with game objects? And so that's done through what's called an XR rig. And I have a diagram up here, so I'm going to try to pull that up real quick. Because I know we made one before. I just don't know where it is. Here. Here. Is this in my presentation? Pardon me. Should be. Interesting. I need to copy one more slide over. go. We love editing our slides while we're presenting them. Also, my escape key kind of struggles to work unless I press with a lot of force for some reason. Okay, here we go. So in Unity, we'll see as part of, like, you'll see this in the VR scene as well, the default. And here we have this sort of game object called XR Core or something equivalent. And within it, we have some game objects. It's kind of hard to see here, so I'm going to try to see if I can make Unity larger. Hold on 1 second. Preferences, editor. There's a way. Oh yeah, you are scaling. 200%. And then we'll restart this application. So I'll show you. There we go. That's a bit more viewable. Okay. So we have our XR core. I'll fully sort of expand it. So within XR core, we have 3 things: the locomotion system, XR origin, XR interaction manager. The first game object is the XR interaction manager. That is the sort of game object or the component I was referring to back a few slides ago with like here. Yeah. So that game object is called the interaction manager, and it has a game. There's just a component literally called the same XR interaction manager, but that's basically the component that orchestrates all the interactions within your scene. Without it, nothing will happen. So you'll need one of those. You just need one, and it can sort of it'll do all that. We have the locomotion system, which we'll come back to later. But finally, we have the XR origin. So the XR origin, or sometimes referred to as the XR rig in Unity, is how your VR player is represented in your scene and through game objects. So you'll have like the 3 things. So you have like this root origin here. So like this parent game object which holds everything. You'll have a game object called camera offset, and then you'll have a series of what are called track devices. And what this are is like these 3 game objects here sort of map 1-to-1 between your VR peripherals and your Unity scene. So main camera is, of course, the VR headset. This is the sort of camera that your player is using to see through the world. So like that. We have your left and right controller, and that, of course, represents the left and right controller within Unity. Oh. I now have 2 controllers. So yeah, left and right controllers represent the left and right controllers through game objects. And so to go back to this slide, so the goal of the origin game object is to just hold everything together. It holds everything else. Everything that basically represents your VR player is nested as children underneath this game object here. You have something called the camera offset, and this game object is used to help sort of offset the player within the rig. So if you want to sort of center the player in their space, so if you can imagine, like, if I want to face straight and I'm like facing off to some direction, then I can manipulate the camera offset game object to help them point right back in the right direction. And lastly, underneath that camera offset is all the track devices, and these are the virtual representations of the physical devices. Each of these sort of devices has a few components. One of them is called like the tracked pose driver. This is basically the component that basically takes the actual position and rotation data as being reported by the providers and applies it to your game object's position and rotation. So to sort of say in other words, it basically is trying to say where is the like controller physically in space in the real world, and once I have the information, I'm going to apply that as like a position and rotation on my game object's transform component. The other thing, like the controllers will have in particular, are what's called the XR controller components. And what these are basically they designate these game objects as controllers, and they also provide all of the quote unquote bindings that let you turn like button presses, like I press the A button, into some sort of action. Like I selected this, I selected like this interactable. So once again, like the controller, what it does is that it's going to take all of, like the complexities and specific things about your controller and turn them into like the interaction states that the interaction manager can recognize. So like using like the grip button on the Quest controller for the select state, the trigger for activate, and as you can imagine, depending on your controller, this might vary a little bit, but generally this is trying to all abstract into some simplified, model. Okay. So once we do that, what we're gonna do first is add some teleportation. So we have a scene, but the player can't really move yet. So the first thing that we want to do, I believe. Oh, my bad. That's actually there. Okay. Before we actually move the player, we're just gonna have the player be to pick up the gun. So what you'll notice here, like if I put on this headset again, is that I'm in the game, but the problem is that I can't actually pick up the gun. Like I'm pressing my grip button, nothing's happening, and my laser pointer is red. So it's sort of indicating to me that whatever you're pointing at is not an interactable, and you need to make it one. So let's do that. First, I need to take this off because that's something we'll come back to later. Okay. So if I look on the floor here and I zoom in, I have the gun here, and if I click on it, you'll notice that in our hierarchy, we can see that it's a prefab. And so this means that we can make multiple copies of the gun, but because I want to edit the prefab for all the guns that theoretically this game support, I'm just going to edit the original by clicking this arrow here. And now we are looking at the gun and just only the gun. So as this slide suggests, we need to make this an interactable. And to do that, we just simply add an interactable component onto our game object here. So if I search up interactable, you'll see that there's many different types of interactables, but basically the one that you'll want most of the time is what's called the grab interactable. And all this does is just let you, it lets you be able to pick up that game object and then do stuff with it. The other nice thing that it provides is that it provides what are called Unity events. So if I scroll down to the bottom here, you'll see that there's this little like checkbox menu. It's kind of hard to see for interactable events. And if I scroll down, you can like you'll see all the states that we talked about earlier with hover, select, and activate. And I guess there's a new one called focus, but oh well. And basically what we can do here is actually like configure things to happen whenever we this interactable, or in this case our gun, like enters one of these states. So I can make it so that whenever like the gun gets hovered, I can trigger something here, like I don't know, I can make what I can do is I can have I can make some 3D text here by right-clicking the gun. Doing 3D object text, font size not -99. Hello. Where is it? Oh yeah, and Unity. Another pro tip: if these icons are ever like way too large and sort of cumbersome, you can turn them off by clicking this checkbox menu up here, and then clicking on 3D icons. That will turn them all off. Should. I don't know why that's still there. It shouldn't be. You can also turn them off individually down here. So now I need to figure out. I'll center it. This text. need a font. Yes. If you want to use TextMesh Pro or like this is like the sort of Unity's components that allow you to introduce like text in your scenes. So like putting up a sign or something like that. What you'll have to do is you'll come up here to Window, TextMesh Pro, import TextMesh Pro Essential Resources. You just click import here. Blah 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 blah. And now just like that, it sort of gives you everything you need to use text. So now if I look again, let's see, 16. I'll try to create it again. There we go. Now I have some text. So I'll just say hover. And basically, using these sort of event things, I will make this. Where did the gun go? Oh, it's still there. It's just really tiny. Okay. I'll turn down the scaling on this way down, like 0.01, 0.01. That way I can actually see it. And then I'll sort of have the text sort of float above the gun like this. I'll make this green or something so it's really visible, even make it bold. But through these events on the interactable, what I can do is like I can hide and show the hover text whenever like the hover state starts and ends. So to do that, I'm going to scroll over to this hover thing. And so we have hover entered. What I can do is I can hit the plus button here to add like a new slot to make something happen. And I'm going to drag our text game object into here. This will like enable this drop-down box here. If I click on that, you'll see a list that shows all the components on that game object. What I want to do is I want to disable it completely. So when I can come here, I can go to game object, set active, and then I want it to show up when we hover it. So I'm going to hit this checkbox for true. And then whenever we stop hovering, I want to come here, do the same thing, drag it over our game object here, set active, and I'll leave this off, and then that will hide it. And the last thing I want to do is if I leave it like this, the hover thing will show like whenever it first starts or it first spawns in. So I'm going to disable it preemptively so that it starts off and like disabled as we expect. So now if I put on my VR headset and I remember where I put my controller. Okay, so here you go. You can see that one of two things happens. One, whenever I like point my laser pointer at this like pistol thing, you can see our hover text shows up. And when I point away, it goes away. I can now, thanks to the power of the grab interactable, when I hit select, it actually comes to me like this. Like I can pick it up, toss it in the air, the whole thing. That's sort of what the grab interactable allows you to do. It'll just sort of like do all this sort of choreography for you, so you can like focus on your stuff. So that's nice. But you'll notice now we still have the problem. I hit the fire button and nothing's happening. So we have still some work to do. All right. I'm gonna hit on. I'm gonna stop the scene. I'm gonna go. So I probably don't want the hover text showing up in the actual game. That's more just to demonstrate to you those different functionality or like that event system or like how you can connect stuff like that. But I'll just sort of get rid of it for now. So well, I'll come back here. I will just hit this minus button here to deactivate those events, and then I'll delete it like this from my scene using the delete key. Now it's just a gun. All right, so we have a gun. We've added the component. Next step, we actually need to make the gun fire. And when we do that, we also want to make the gun like play some pickup or sounds to indicate that like it's shooting. You picked it up and you've released it. So to do that, we're going to actually take advantage of those same event systems that I mentioned before, but we're actually going to put it to work. So the first thing to take a look at is we have a component called gun And if I come down here, hit these dots and edit script, you'll see that my IDE is slow. Oh, there we go. Trust and open. Like loading. There we go. So we'll see this component here. We have a public method called fire, but we need to add some code here. This is in the form of comments. And we also have a coroutine that is sort of built for us that will basically, what it will do is you will give it a game object and some time. And what it will do is it will wait for that amount of time. And after that, it will destroy the game object. And we'll see how this will come in handy in a bit. So what we now want to do is we want to configure our gun object to call this fire method whenever it's activated because you pull the trigger. And we're also going to do some other fun things like have it play some sounds when you pick it up, drop it, that kind of thing. So the first thing I'm going to do is come to the select state, and I'm going to add some slots. I'm going to add 2 here, 2 here. And what I want to do is when I pick it up, I want it to play like a sort of like a or like a a sound that represents it being picked up. So I have it here in the audio folder. I will attempt to have my sound loud enough for you to hear it. They changed the sound UI in Windows 11 today. That's great. How do I change my speaker? I think like this. There we go. Okay. Might sound like this. So that's the pickup. And then here I have a release sound, like putting it back on the ground. Whether or not that's accurate to a real gun, I don't know. Don't at me. But what we're going to do is actually have these sounds play when we pick it up. So to do that, I'm going to come to the grab interactable and the select component. What I'm going to do is I'm going to drag in the gun here like this in both slots. And the 2 functions I'm going to set are first audio source, and then going to come down here to static parameters and click on clip, and then audio source, and then come down here. There's this play method here, and I'm going to click on that. What I'm going to do next is I'm going to simply drag the pickup sound into this clip thing. So what did I just do? So first, what we're going to do when we pick up the select is that we need to set the clip of the audio source to the sound we want to play. So this is sort of, if you could think about it, like if we think about this in the context of like a CD player, we have like our sound, the pickup sound sort of symbolically on the CD, and we are going to put it in the source, or in this case, like the CD player. We're going to prime it to play the sound. And the very next thing we're going to do after we load this pickup sound is called the play method on the audio source, and that will actually play the sound. And what we're going to do, and then once we drop the weapon, we're just going to set the exact same sort of behavior. I drag in my gun game object that has my audio source component. I click on this drop down, audio source, clip. I come in here with the release sound, and then I call play. Bada bing, bada boom. I save with Control S. And now if I come back to the scene and start it up, ow. Now you'll notice when I pick up the gun, it plays that sound. If I let go, it plays the release sound. Pick up, release, pick up, release. And to kind of tie them back to those interaction states we talked about before, this is select, and then get out of select, or no longer select, select, no longer select. Perfect. But you'll notice that, we haven't programmed an activate state yet, which is like what's actually going to fire the bullet. So I'm hitting the trigger, nothing happens. We need to do that ourselves. So to do that, we're going to do both some configuration and some Unity coding. So I'm gonna go to exit play mode. Gonna go in the gun, and much the same as before. Oh, not here. I'm gonna go to the activate state down here, and I'm gonna add 3 slots. The first thing I'm gonna do is just like we did before. I'm gonna have it play a sound. So I'm gonna drag in the gun components, go to the audio source, set the clip to this gunshot sound, and then click. Then right after that, activate the play method. So this will play our gunshot sound whenever we hit the trigger. Perfect. But now I actually need it to fire like a bullet. So I've started us off here with like we have this method called fire. So it doesn't have any code yet, but what we can do at the very least is tell Unity to call this method in our gun component class. So what's nice about this event system and everything like that is that any public method you show that's takes in either one parameter or less will show up generally in this menu here. If it's private, it's going to disappear. But because this is just a public method called fire, it will show up in the list. I also forget whether or not the return type matters, so I'm going to try to return like 3 or something, see if that changes anything. Let that compile. Yeah. Okay. Yeah. Okay, yeah. So it does need to be void, or rather that you cannot return anything, otherwise it won't show up. All right. So I'm gonna let that compile, and now I come down here. The gun, our fire method is back. Great. Now when we pull that trigger after we pick up the gun, and I hit the activate, it's actually going to play that gunshot sound and then call this fire method. But we actually now need to have the gun actually fire something. So we come to our IDE here, and we see 3 things we have to do. We have to create the bullet that will spawn out the front of the gun. We have to give it some force so it actually shoots out. And we then need to start what's called a coroutine to destroy the bullet after the time specified in the time before destroying bullet variable. The reason we have to do that is you can imagine that if you just sort of go willy-nilly like pew, 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 you're going to create a bunch of bullets, and they might sort of get like, they might end up on the floor and then reach a resting state. But then you just sort of have like all these bullets that you're managing, and you want to clean them up. Like you want to make it so that like if they haven't hit their target after some amount of time, or they've sort of come to a stop, we get rid of them. It saves on memory, saves on performance, yada yada yada. So the first thing we want to do is sort of take a look at what we're given. So we have a bullet prefab game object here, or rigid body here, a bullet force, the aforementioned time before destroying bullet, and a fire transform. If we look at the comments, the bullet prefab is the thing, sort of the thing that we're going to spawn in and duplicate and to fire off. Bullet force is the amount of force that we're going to apply to the bullet to get it to go. Time before destroying a bullet is the time we're going to wait in seconds before we destroy it. And lastly, we have what's called a transform here, a variable called fire transform. And this is going to allow us to specify which game objects transform we want the bullet to spawn out of in like the forward direction. So you can imagine we have like our gun, right? But the problem is that maybe the gun center is at like in the handle, and we don't want to spawn bullets from within the handle. We want to have a transform, or we want to be able to specify that we want the bullets to come out the front of it. So this is what this fire transform is going to allow us to do. So we're going to go ahead and do it. I just need to pull up some notes myself to verify. Yep. Scripts. Okay. And I need to go into the here. Go. Bing, bang. All right. Sorry about that. Okay. So first, to create our bullet, we're going to use the instantiate method of Unity. This is a method that will basically allow us to either copy or duplicate something to create something new. So to do that, I am going to make a variable to keep track of the bullet that we fired, called bullet. We'll use this variable to store whatever the bullet that we've created. That way, later on, we can actually add a force to it, and we can also queue it to be destroyed after some amount of time. Next, I'm going to set this bullet variable to a new bullet, and to do that, I'm going to call instantiate, and I will. You'll see here, it's kind of hard to see from this preview, but we need to give instantiate the thing to copy, and then we can also give instantiate a position and a rotation that will to allow us to specify where we want the bullet to spawn out of. So I'm going to call bullet prefab here as the first parameter. So this is telling Unity, okay, we have this bullet prefab. I want to make a copy of it. Right? And what I want to do is then specify the fire transforms position and the fire transforms rotation. So like this, kind of, we can come up to the front. What this is saying is we're just going to copy the bullet, we're going to specify the prefab, give it the position of wherever game object represents where we want the bullet to come out of. We want to put the bullet at that position, and we also want to give that bullet the matching rotation of the fire transform so that if the gun's pointed up, it fires up. If the gun's pointed down, it fires down. All right. That's it. Voila. We have our bullet. But if we were to run our game right now and we pull the trigger, the bullet would spawn in, but it would instantly drop to the floor because there's no force. So to actually make it a gun, we have to propel it. And we're going to do that via the variable we've created here with the bullet rigid body variable. So, excuse me. We have a method of the rigid body called add relative force. And we're going to set this to a vector 3 because we represent forces via, if you've taken a physics background, we can basically split any force into their directional components. So in 3D space, we have a x, y, and z component. So you can x being left and right, immediately y is up and down, like that, and z is forward and back. So we can take our force and express it given some left and right component, forward and back component, up and down component, and we can express any sort of direction like this. In Unity, the forward direction, is usually represented by the z vector. So what I know now is, I don't want to make the bullet go left. I want it to go straight. So I'm not going to add any left and right component there. I'm just going to zoom in a bit more. I don't want to make the bullet go up and down. Just want to make it fire straight out. So another 0 there. And lastly, now here's where I'm going to put the force in. I want the bullet to spawn out or to shoot out. So what I'm going to do is going to make the z component of it called bullet force. Once again, bullet force is this variable we specified here. And that way we can also configure the force of the bullet from Unity. So if we want the gun to have stronger bullets, we can make the force come out faster. We can increase the force so it goes out even farther. If we want weaker bullets, we can turn it back down. Last but not least, we want to destroy the bullet after some time. So to do that, or what I'm going to do is in Unity, whenever you have a coroutine or something that sort of happens over time, we can start a coroutine by using the start coroutine method. So I'll just call that, and then I need to pass in our coroutine. So in this case, I'm going to make our coroutine using this method down here called destroy after time. So I'm going to be specifying that here is destroy after time, the bullets dot game object, and the time before destroying bullet variable. Okay, so to break this down, we are going to start a coroutine so that a Unity will actually execute it. So we're going to make it using this function or method here, and we specify the bullets dot game object. The reason we do this is if you just specify bullets itself without this dot game object, what will happen is that Unity will take it quite literally, and what it will do is that it will destroy the rigid body component of the game object, but not the whole game object itself. So what that means is that basically Unity, if you didn't have this game object here, Unity would literally just make this no longer a physics object of the world. It would just freeze there, and nothing could interact on it, nothing would remove it. It would just sort of freeze in space. So every component has a dot game object connected with it, and that gives you a reference to whatever game object is attached to. And so now we're telling you here, no, we don't want the entire bullet to just disappear, and we specify the time here and time before destroying bullet. And just like that, that's it. The gun should be firing now, so we can go back to Unity. I can take another look at this gun component. So you'll notice here, we have our bullet prefab here. This is like the copy of the bullet that we're going to figure out or shoot. If I double click this here, you can see that it's this sort of metallic sphere thing. It's got a sphere collider and a rigid body, as you expect, because this bullet has some mass to it. You can apply a force to it. It's got a sphere collider because we're having like spherical bullets. Yada yada yada. We have our force configured for 75. I guess it's newtons, but force units, whatever. We have 3 seconds until we destroy it, and our fire transform is here. So if we click here, you'll notice that on the hierarchy on the left, it highlights this thing in yellow, and this game object is literally an empty game object. So once again, this is a use of having game objects with no components for like this. I have this game, if I look closely here, you can see that this game object is positioned just outside of the barrel with the blue Z or forward axis facing this way. And so basically this is us telling Unity that we want the bullets to come, or our component that we want the bullet to come out of here. I could change this up to anything else. So I could drag in, I don't know, like this cube thing into here, and then now wherever this cube is, like the bullets to spawn out of here. We don't want that because that wouldn't be ideal. We want it to come out the front, so we will make sure to use this fire thing like that. Okay, now we got that. I can go into Unity and let's take a look. I pick it up, we get our sound, and then there you go. I don't know how well that comes on the screen, but see, we're firing bullets. I can fire them at the ground, sort of. You'll notice that they're actually going through the floor. One thing that you can set to sort of prevent that, I think, is you can say, you can go to your rigid body, so we know that's, you can usually come down here and switch it from like discrete by default to continuous, which sometimes fixes it. But in this case, it might be just going too fast and going through the floor, but I wouldn't worry about that. So what I will do instead is, this is one of the great things about Unity. I'll decrease the force temporarily so it doesn't like literally rocket it out the front. It does it much more gently. So now if I pick it up, yeah, see, now it's hitting the floor. But you'll notice that, see, that bullet existed, and then after 3 seconds it went away. So I fire it, the bullet rolls, and then 3 seconds, boom, it's gone. So that way, we're not just wastefully just keeping too many bullets falling around and stuff like that. All right, Cool. And oh yeah, the last thing I'll show here is that, you know, one of the great things about Unity 2 is that you can actually edit all these values while Unity is still going. So if I put back on my headsets, you know, I can come back up here, and this force variable, I can turn it back up to 75, not Y5, that's not a number, 75. There we go. And if I pick up this gun again, without making any code changes, without, you know, setting Unity back into play mode, exiting play mode, now the bullets are coming out with full force. So that's a really great technique. If you're ever debugging something or you want to make sure that stuff is working correctly, just make it a public variable or serialize it with a serialized field attribute. And you'll be able to manipulate like this, and then it'll be great because it'll help you kind of tweak things. One thing to note is that when you do this, whatever values you had before you started tweaking them will be preserved. So if you started play mode with like the bullet force of 5 and you changed it while you were in play mode, it will revert back to whatever you had before you started. So I'll set this back to 75. Great. Okay. So we have our bullet. We can fire our stuff. Now we need to actually, what we'll do next is we will add what's called a teleportation area. So right now we can't move. Damn. We need to be able to move. So we usually VR games will do this in one of two ways. We'll do this in terms of either teleportation or what's called smooth locomotion. I think I have a slide here actually about it. Yeah. So teleportation is usually sort of preferred if you have anybody new in VR because it's much more easy on the senses. So the idea is that basically you'll identify some points or some place to teleport to. So I guess across the room, you hit a button and then like fade to black, boom, you teleport and then you fade back in and you're there. And this is nice because this tends to reduce your perceived motion sickness. So it's like a really nice way of getting beginners in and you won't vomit as much. Some players, like me, prefer something called smooth or continuous locomotion. And what this means is that basically, as you would control some other video game character, you're controlling your virtual avatar or yourself via a thumbstick or like on the controller. So for example, with this Quest here, like through this thumbstick, and this will allow you to like basically like if I want to go forward, I push the thumbstick forward. It is a lot easier to control your movement in this way, but you run the risk that, you know, some people can get nauseated when you when you move them and they're not actually moving in real life. Yeah, but it's something of note. For now, we'll implement teleportation, which allows us to do the comfortable way. So this is what's nice about the XR Interaction Toolkit. We actually don't even have to do any of the hard work. There's usually just a component given to us called teleportation area. All we have to do, add it to the plane or our surface, and we can teleport. So I'll come down here to the plane. This is like sort of the area that we'll be maneuvering in. I come down here to add component. I just click it. I search at teleportation area. Boom. Bob's your uncle. I don't know why we say that saying, but now we have teleportation. Easy as that. So when I go back into Unity or into VR, like this. Now if I hit the select button, that's weird. Oh, I can kind of see why it's doing that. That's interesting. But now I can teleport around just by pointing on the floor. So great. We've imported. We've done teleportation. Now the last step we need to do is actually add some enemies to fight against. And I'll set this down. Okay. For enemies, I've had this prefab here already made for you called Headcrab. All my excellent 3D modeling skills have been put to the test. I know. You're so jealous. But, okay. So, to spawn in our enemies, we have this game object here called Femur Arena. And this is sort of like a manager game object. It sort of choreographs what happens in our game. And you'll notice here that the component is set up so that it should have everything it needs to start spawning these enemies in, but it's not because we have to provide that logic ourselves. So you'll notice here that we have the head crab, which does point to the head crab performance. We have a spawn transform, which basically allows us to specify, where we want these enemies to spawn in. We have a target transform, which allows us to specify where these enemies are going to move towards to actually target you. And that is our main camera, because we want them to follow wherever your head is, because they're head crabs, your head, whatever. And we can also specify things like a spawn radius, so we can make them spawn, randomly within like a larger or smaller region. We can specify the interval in seconds, so we'll spawn a new head crab every 2 seconds. And lastly, we can specify a limit. So I only ever want 5 head crabs to be present at one time. So if after if we keep counting 2 seconds and then spawning, we reach 5, we won't spawn anymore. So to do that, I'm gonna come here, click on Edit Script. This will point us towards this script here. We see all of our variables here, and we see a coroutine here that has some holes to fill in. We already kind of have the gist of it. So basically what we're going to do is we're going to spawn this, and we're just going to carry out this logic and then wait out. So once again, what's nice about a coroutine is that we can actually, what coroutines really allow you to do nicely is kind of wait for some amount of time before doing something else. That's why you can't just use the update function or method here, or the event function, because you can't really wait in the update function, because the update's supposed to happen every frame. So if you're waiting while you're in update, you're going to start blocking everything else from happening, so your game will freeze. And so coroutines allow us to tell Unity, hey, I'm going to do these things, then I'm going to wait for some time, you go ahead, do whatever else, and then after 5 seconds, come back to me. So that's the power of coroutines. So the very first thing we're going to fill in is we need to actually start this spawn coroutine. And we've seen this before. What we're going to do this is all we have to do is use that handy old start coroutine method, give it our spawn coroutine. We're going to make one with spawn coroutine, and we're going to tell Unity to start executing it with start coroutine. Perfect. Now we're going to be creating, or now this loop here will get executed, but we have to fill in the stuff. So before we do that, we can look at the basic loop structure. All this is saying is, while true, or indefinitely, we're going to check if the total head crabs that exist through this static integer variable here of head crab is less than the limit. Then we're going to do these steps to spawn in the head crab. After we do that, or whatever, we're going to wait for the spawn interval, which will basically wait 2 seconds until spawning the next one. So to determine, the first step we have to do here is determine the spawn location. And we want to basically take we have the circle defined here. We want to find some random point within that circle and spawn them in. So bear with me, because we're going to do some math. I know. Everyone's favorite. So first, we're going to get the center of the circle. And so we're going to first make a variable called vector-free spawn position. And we're going to set it equal to the spawn transforms position. So basically, this is going to make our spawn position right now in the center of the circle. That's fine, but that means all the enemies start from where we do, just there. They never vary. So now what we want to do is basically offset this to go on the edge of the circle and then rotate it in some random direction so that they just spawn on the outskirts, but they come towards us slowly. So to do that, we can do this little math Unity rotation technique called quaternion.angle axis. So basically what we want to do is we want to add to the spawn position by a quaternion angle axis random.range 0 to 360 degrees. vector 3 dot up times new vector 3, or actually we can do spawn radius times vector 3 dot forward like this. I will fix this error. Why are you mad? Yeah, okay. So what did I just type out? So here, what we're basically doing is we're gonna first pick some random rotation around like the up axis between 0 and 360 degrees. So like I have this, the up axis is like literally as it implies, like pointing up. So this is basically our up axis, and I'm gonna pick some random rotation around this between 0 and 360 degrees. Right? So that basically will allow us to say that we're gonna randomly rotate whatever we apply this rotation to around. We're gonna spin it randomly between 0 and 360 degrees. To make it actually do that to our spawn position, what we're going to do is take the forward direction, or like the direction pointing up forward. We're going to scale that up to the spawn radius. We're going to get that to appear on like the outer edge of the circle by multiplying it by our spawn radius. So if we want all of our enemies to spawn 5 meters out, we're going to multiply that forward vector, which just has like a 1. So the forward vector is just like this. It has no left and right component. It just has a forward component of 1, and we're just going to multiply that whole thing by our spawn radius to just get it to spawn out in some direction. Once we do that, once we have that vector, we're going to rotate this, rotate that vector around the y-axis in some random direction, and then that will get us to have some random point along the edges. So it is kind of confusing to see it like this in text form because you don't really see the order of operations. Because basically, I think rotations are applied right to left, I believe. So what's happening is at first, this vector is being created and extended out first, and then we're rotating it. Because if we did it in reverse, if we first had our spawn radius, or if we first rotated like the origin, then nothing would happen. So we have to actually go out first. So I'll kind of try to quickly draw that graphically to kind of represent what I'm talking about. So once again, so we have like some circle that we want to be in, like this, right? Like that. We have like the spawn position, which is like the center of the circle here. I start off with the forward vector, so that points forward. And what I do is I multiply that by the spawn radius. That will allow us to extend this vector all the way out to the edge of the circle. And then I randomly rotate around the y-axis in some direction, like 45 degrees. That will spawn it, and that will allow us to put the point on this edge of the circle. Okay, that was a lot, but basically in gist, what that does is that basically puts the spawn position at some point randomly along this blue spawn circle here. Great. Perhaps. But once you get sort of versed in this Unity rotation stuff, it does become easier over time. So next, we will have our spawn position, but we need to actually make the crab start off facing the player. And what Unity can do, which is nice for us, is sort of do all the hard work for us. So what we really want it to do is wherever we spawned, we want to look at the center. And we can do that by using this method here called, so we'll first make a rotation variable called spawn rotation, and we'll call the method quaternion.lookRotation. And this will take in 2 parameters. First, the forward direction we want to look at. So basically, where am I looking at? And then an up direction, which allows us to specify, what direction, in what direction is my head pointing up. So if I specify up, that means like I'm looking this way and my head's up. But if I specify like right instead of up, that means I'm looking that way, but my head's like this, We want the crabs to spawn upright, so we specify vector3.apt. So we can specify the up direction as the second parameter. The first parameter is the one that we need to think about. So if you have taken linear algebra, blah, 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 we can get the direction that we want to face by doing like a sort of, we can subtract where we want to end up from where we are now, like a final minus initial. And this will give us like the direction that we want to face. So we know that we want to face the center of the circle. So I will put in the spawn transform.position variable first. I'm going to subtract that from where we are now, which is whatever value we have here in spawn position. That will allow us to say, or that will give us the direction we need to face. Just like this, we have the rotation we have the rotation to put the crab in. Now we just need to spawn the crab. That's much easier. So I'll have a head crab component here called crab, and I will call the instantiate method to copy it from the head crab prefab. I will spawn it at that spawn position we calculated here, and then I will give it the rotation called spawn rotation that we have calculated there. All we need to do is now specify the, the target. So these head crabs have, these head crab components have a public variable called target that basically represents the thing that they're going to be attracted towards. You can take a look at that code on your own time if you want, but we're just going to set it here as crab.target is equal to our target transform. So this is saying that we want, for this crab that we just recreated, we want it to point this way. Now, that's all we need. So if I come back here, I hit play, and if I go to the scene view, turn off these 3D icons that are annoying, you can see that slowly but surely we have our crabs here that are moving towards the center, and then once they get to the center, they'll try to jump on your face. Hurrah. So, the next step is, you'll notice if I go back into VR mode that these crabs spawn in just fine, but I can't shoot them, which is kind of problematic. So how am I supposed to win if I can't, actually... hold on a second. Oculus disconnected. Hello. This. Go. Come back. I hit play again. PC disconnected. That's weird. Quest is being Quest, so I don't know. I'll try to get that working later, but I know we're running out of time. So basically, the problem is that we have our crabs; they spawn in, but the issue is that we can't actually shoot them because we haven't told them to like do anything when they're being shot. So for here, we're gonna do finally, as the last part of this project, we are just going to go into the bullet code and or excuse me, the head crab code, and add a collision event function that will just tell us to do, or allow us to actually destroy the head crab when it gets hit. So come here. All right. So I have this sort of starter code here. This uses the onCollisionEnter event function. Somebody last time asked, how do you know if you've hit like collided with something in particular? This is a use case of that. We first check this collision object. We get whatever was collided, and we call this method called compareTag, a bullet. So basically in Unity, we can also specify what are called tags on game objects. So I have a tag here called bullet, and this basically says, does this game object or collide or whatever have this tag called bullet? If it does, great, I execute this. First, I'm gonna play a hurt sound, like because ow, like the crab got hit by the thing. Or sorry, I'm gonna play a hit sound because got dinked or whatever. So all I have to do here, okay, gonna just play. I have this reference here to my audio source component called audio source. All I'm gonna do is just do audio source at play because we already have the clip of the hit sound loaded. I'm just gonna call play to make it actually do the thing. Next thing up is I want to destroy the bullet because the bullet has now collided with the crab. So now I want to destroy it because it's collided, it's done its job, time to go. So all I'll do is call a destroy method with the collision.collider.gameObject. So what this sort of chain of thing is doing is from the collision information we're given, we're going to get the collider that was actually collided with. So that sort of boundary of space, or the collider component that tells us like what boundary of space that the game object has. And like I said before, every component has a .game object that refers to the game object that it's attached to. So we're going to follow that to get to the game object. That way we're going to destroy the whole game object. Just gone. Lastly here, we're going to do a start coroutine of the shrink and die coroutine. The shrink and die coroutine is what's defined down here. All this basically does is the crab, once you call it, will shrink into like a very nothingness and then get destroyed. So it does this by basically keeping track of the time that's elapsed so far, and then slowly turning down the scale until it reaches nothingness. And another thing you'll to note about coroutines is usually we'll see yield return some wait for seconds, but if you specify yield return null, that basically says wait until the next frame. So if I have 60 frames per second, I call yield return null. 1/60th of a second later, this will be called again to do whatever. All right, so that's now we can respond to bullets. And the last thing we need to implement to have a finished game for tonight is just the logic that what happens if we collide with the player. So this is some C#. Yeah.
What happens if you change the frame rate when you do that?
Okay, so I think it might not actually be based on the. So I might have made a mistake. It might not be based on the actual frame rate, but just the fixed time. So that always happens at usually 1/50th of a second. You can specify changes in the player code, but in this way, it should happen probably based on the fixed time. So it shouldn't matter what your frame rate is. So good question. Okay, all you have to do here to get the player to we want to make a sound that says "ouch, I've been hit." So I have made this method here on the player called play hurt sound. If I follow that through, you can see all it's doing is it's just getting the audio source component that has our clip of the hurt sound and just calling play on it. That will play it. Boom. And the next thing I want to do is I want to destroy the crab because now that the crab has jumped on the player is hurt, but now I'm done with the crab. I'll just get rid of it. And I can do that by just calling destroy game object, much in the same way before that we got the game object of the components using the .game object. Since we are the component, I can just come up here to game object and get rid of myself. Yeah. But yeah, once this is in, all the pieces are in place. We now have a fully functional game. All I have to do now is pray that Oculus Link works again after I've disconnected, reconnected, etc. So I'm going to do that real quick. Like this. This. Launch up the Quest. And there we go. I got video, so now I'm going to come up here into where's my mouse? Here it is. Play. I can pick up my gun. You'll notice that the crabs are coming towards me in all directions, and if I shoot them, they play the hit sound, disappear, like that. But now, for sake of argument, if I let them attack me, they'll jump up and. Ow! Yeah. So, hoorah! Our very cheap Netflix adaptation, free version of this game. You can have literally minutes and minutes of enjoyment before you get bored. But yeah, that's all it takes. So, and like in conclusion, you just think of everything in terms of interactors and interactables, alternate between those states, and then utilize them to create the interactions you want, and you have a game. So, voila. This your if you want to look at the finished code or follow on later along, because it's sort of easier to do that like your lab. It is available in our GitHub here at UMD's GitHub called Femur Arena. It's public, and there's like a main branch and the finished branch. The main branch is like the starter code. The finished branch has all the finished code. Only problem being is that I accidentally overrode the finished code with the main code. The unfinished code, I'll fix that. But I'll put this in a post on the resources channel, so that way you can follow along on your own time. And with that, yeah, that's about it. We have made our game, so I'll sort of switch back to those QR slides. But I thank you all for coming tonight. And yeah, enjoy your Tuesday. We'll see you Friday for VR night. So if you want to try a bunch of VR experiences that are way better than what I made, whatever I threw together, yeah, feel free. But other than that, have a nice night, and I'll see you all later.